Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about introduction of green chemistry and need of green chemistry and principles of green chemistry and methods of green synthesis. So nowadays, to meet the demands of modern civilization, so variety of chemical products and industries have evolved. So which lead to the formation of hazardous substances. So in modern civilization, so many industries evolved, so many chemical products also, they are novel chemical products synthesized. So it leads to the formation of hazardous substances. They are released industries, from that industries it releases so many hazardous substances. So this is harmful for our human health and environment also. So in order to prevent or minimize the formation and use of such hazardous substances, so the chemists are required to develop the novel technologies which has inspired the generation of new branch of chemistry. So that is called green chemistry. So nowadays it develops in modern technology, so many industries evolve and so many novel chemical products also evolve in that. So but this leads to formation of so many hazardous substances. So it causes bad effects on environment and human health. So many new diseases also came in that. So in order to prevent or minimize the formation and use of such hazardous substances, so it's the chemists are required to synthesize or develop novel technologies which are not harmful for environment, do not such a harmful effects on environment. So that novel technologies which are inspired that new branch of chemistry that is named as green chemistry. So here green chemistry, it is also called as sustainable chemistry. It is also called as sustainable chemistry. So it is an area of chemistry and chemical engineering. Here that chemical engineering focused on the design of products. That chemical engineers or the area of chemistry, it focused on the design of products and process that minimizes or eliminate the use and generation of hazardous substances. What is the main aim of this green chemistry? So this chemistry is also called as sustainable chemistry. So the chemist designs mainly focused on the design the products and process that minimizes the hazardous substances or elimination the use and generation of hazardous substances. So what is the difference between environmental chemistry and green chemistry? So here environment chemistry mainly focuses on the effects of polluting chemicals on nature. So what are the harmful effects on environment? Mainly environmental chemistry focus on the effects of polluting chemicals on nature. But green chemistry focus on the environmental impact of chemistry and including reducing consumption of non-renewable resources and technologies, approaches for preventing pollution. So it focus on that both environmental reducing the consumption. It's including reducing consumption of non-renewable resources and technologies, which approaches for preventing the pollution. So what is the main definition of green chemistry? So green chemistry is a branch of chemistry which designs the chemical products. So green chemistry, it is also called as sustainable chemistry. What is the definition of green chemistry? It is a branch of chemistry which designs chemical products and process that minimizes the use and formation of hazardous substances is known as green chemistry. So in this green chemistry, we synthesize so many products, but that is not harmful. It avoids elimination of hazardous substances. That is the main aim of green chemistry. So here, the main goal of green chemistry is to create better, safer chemicals. In this green chemistry, we synthesize chemicals, chemical products are better and safer chemicals while choosing the safest, most efficient ways to synthesize them and to reduce the wastage. So the main goal of green chemistry is to design chemical product which is not harmful for the environment. And there is a atom economy also. There is no wastage. Reduce the wastage. Improve the atom economy. 100% efficient of product we can obtain in that green synthesis methods. And that is not harmful for any environment or human health also. So this green chemistry mainly tells about waste minimization of source and use of catalyst in the presence of reagents and using non-toxic reagents and use of renewable sources and improve atom efficiency. So it tells about mainly minimization of waste, reduce the waste and use of catalyst, the green catalyst we are using for and do not harmful for anything. Do not produce any harmful substances. So use of catalyst in the place of reagents because reagents are the most main cause of pollution. So use of catalyst in the place of reagents, we avoid the hazardous substances or pollution. And using non-toxic substances or non-toxic reagents. And use of renewable resources and improve the atom efficiency. That means 100% product we will get in that method, green synthesis method. There is no wastage of any product or less wastage in that chemical product synthesis in this green synthesis methods. So what is the need of green chemistry? So already we know that in the 20th century, very successful and highest scientific development with respect to various benefits to the mankind. But all this was responsible for a number of environmental problems at the local and global levels. So already we know that in 20th century we are discovered so many chemical products. But here it leads to the environmental problems, local and global levels. So industrial discharges, pesticides, herbicides fill the sky and seas. So our technological power is increased day by day, but the side effects and the potential hazards also increased. So in that green chemistry concept is to avoid the toxic substance. So what is the main goal or aim of green chemistry? To avoid the toxic substances and reduce energy requirement and use renewable materials. Use of renewable materials. So green chemistry includes any chemical process or technology that improves the environment and thus our quality of life. This is the main aim of green synthesis, green chemistry. So green chemistry, it is also called as sustainable chemistry. It designs chemical product and process which is not harmful for the environment and improve the quality of life. And next we'll discuss what are the principles of green chemistry. So the green chemistry concept applies innovative scientific solutions to solve environmental issues posed in the laboratory. So these principles were introduced by Paul T. Anstas. He is an organic chemist working in the Office of Pollution Prevention and Toxins at the EPA. And John C. Warner developed the 12 principles of green chemistry in 1991. So these principles can be grouped into reducing risk and minimizing the environmental footprint. So these principles can be grouped into reducing the risk of harmful substances, chemical toxins. So reducing the risk and minimizes the environmental footprint. So what are the 12 principles of green chemistry? So here, these are the 12 principles of green chemistry. So first one is waste prevention, atom economy, less hazardous chemical synthesis, designing safer chemicals, safer solvents and auxiliaries, design for energy efficiency, and use of renewable feedstocks, reduced derivatives, design for degradation, and catalysis, use of catalyst in the place of reagents, safer chemistry for accident prevention, and real-time pollution prevention. So these are the 12 principles of green chemistry, mainly used for to avoid the toxic substances and improve the quality of life. So here the principles of green chemistry, there are 12 principles of green chemistry I introduced. In that first one is waste prevention. So it is better to prevent waste than to treat or clean up waste after it has been created. So waste prevention, where you can reuse this one, we prevent waste. So for example, certain lipid kits for life science research. And second principle is atom economy. So here synthetic method should be designed to maximize the incorporation of all materials used in the process into the final product. So improve the atom efficiency. That means 100% efficiency of product we can get. There is no wastage. Improve the atom economy by using this green synthesis methods. And less hazardous chemical synthesis. So wherever practicable and synthetic methods should be designed to use and generate substances so that poses little or no toxicity to human health and environment. So when we synthesize the chemical products in this green synthesis methods, these are less hazardous, not harmful. So the type of chemical products we can synthesize in this green synthesis methods. And next one is safer solvents and auxiliaries. So the use of auxiliary substances such as, for example, solvents, separation agents, etc. should be made unnecessarily wherever possible and incautious when used. Example, green solvents or methanol, acetonitrile, etc. These are the safer solvents used in this synthesis of chemical products by using green synthesis methods. And next one is design for energy efficiency. So energy requirement of chemical process should be recognized for their environmental and economical impacts and should be minimized. So if possible, synthetic method should be conducted at ambient temperature and pressure. So for example, this design of energy efficiency is green antibodies and certain biostabilization agents like dimethyl sulfoxide we can synthesis in this green synthesis methods. And next one is designing safer chemicals. So the chemical product should be designed to affect their desired function while minimizing their toxicity. For example, biorenewable solvents like serine, dihydrolivoglucosans. And next one is use of renewable feedstocks. So raw material or feedstock. So raw material should be renewable rather than depleting whenever technically and economically practicable. For example, greener solvents like ethanol or methanol. So do not harmful for the environment. And next, reduce the derivatives. So unnecessary derivation, use of blocking groups, protection, deprotection, and temporary modification of physical and chemical process. So should be minimized or avoided if possible because such steps require additional reagents and can generate waste. So reduce derivatives mainly. And next, catalysis. So here catalyst generally used for to speed up the reaction. So we are using catalytic reagents as selective as possible. That means catalytic reagents are superior to stoichiometric reagents. Generally, our normal reagents mainly cause for pollution. So instead of that, we are using this green catalyst in the place of reagents. We can reduce the emission hazardous substances. Example, synthetic reagents and organometallic and building blocks. For example, triphenyl phosphine alkyl diene used as a catalyst. And next one is designed for degradation. So this chemical product should be designed so that at the end of their function, they break down into degradation products and do not persist in the environment. That means these products which are synthesized in this green synthesis method, that is easily undergoes degradation, do not harmful for environment. And next principle is real-time analysis for pollution prevention. So in this analytical methodologies need to be further developed to allow for real time. So in process monitoring and control prior to the formation of hazardous substances. So in this we can reduce the pollution, environmental pollution. And next, inherently safer chemistry for accident prevention. So the substances and the form of substances used in this chemical process should be chosen to minimize the potential for chemical accidents. So it's including releases, explosion and fires, etc. So these are the 12 principles of green chemistry. These are mainly used to improve the quality of life and reduce the environmental pollution. Do not harmful for the environment. Do not produce non-toxic toxic substances. This is the main aim of these are principles of green chemistry. Next we'll discuss methods of green synthesis. So here chemistry plays an important role to develop our quality of life and achieving sustainability on earth. So this green chemistry or chemistry plays an important role to develop our quality of life and achieving sustainability on earth. So all over the world using advanced knowledge to develop new synthetic conditions. So all over the world nowadays they prefer green synthesis method because these are not produce hazardous substances, reduce the wastage and get the 100% efficiency of product. There is no wastage. So that's why all over the world they prefer this new synthetic conditions, develop new synthetic conditions like aqueous method, solvent free in that, and microwave induced method and phase transfer catalyst, etc. So these are produced pollution free environment. That's why in all over the world they prefer this green synthesis methods. So here in this most important green synthesis methods are aqueous phase method, microwave method, phase transfer catalyst and ultrasound method. So there are the four different green synthesis methods are there. The main aim of all the four green synthesis methods are to avoid the toxic substances and improve the quality of life. And we can get a waste, minimization of waste and improve the atom economy, atom efficiency, 100% efficiency of product we will get in that methods, in these methods. So now discuss aqueous phase method for green synthesis. So here aqueous phase method, we are using green solvent in aqueous phase liquid state, do not harmful for environment. So here environmental pollution is mainly caused by organic solvents. So now all over the world have been trying to carry out organic reaction in aqueous phase, because water is a green solvent, do not toxic substance. So all over the world they have been trying to carry out organic reaction in aqueous phase. So the advantages of using water as green solvent. and it is a low cost, non-flammable and highly specific heat resistance, unique enthalpic and entropic properties and easily handling. So that's why we synthesize this products in aqueous phase, green synthesis method in aqueous phase. So because water acts as a green solvent and it is available in less cost, non-flammable and specific heat resistance, unique enthalpy and entropic properties and easily we can handling. So that's why we synthesis in the aqueous phase. The most best example of this aqueous phase method for green synthesis is Newangel reactions. Newangel reactions. So what is the meaning of Newangel reactions? So here the condensation of carbonyl compounds. Carbonyl compounds means it contains C double bond O group like aldehydes, ketones, esters, etc. So the condensation of carbonyl compounds with active methylene compounds. The active methylene means it's present, methylene group present in between two carbonyl groups. So electrophile, that means here. So the condensation of carbonyl compounds with active methylene groups in presence of weak base like ammonia or amine or pyridine. So is known as Newangel reaction. So what is the meaning of Newangel reaction? The condensation of carbonyl compounds with active methylene group in the presence of weak base. For example, weak base means ammonia, amine and pyridine. So this type of reactions are called Newangel reaction. These are the best example of aqueous phase green synthesis methods. So here condensation of carbonyl compounds. For example, here we are taking carbonyl compound is aldehyde. Here R means any alkyl or methyl, ethyl, anything here. So carbonyl compound means here we are taking aldehyde. Reacts with active methylene groups. So methylene group present in between two carboxylic groups. It is called melanoic acid. The structure name is melanoic acid. So the condensation of this carbonyl group aldehyde and melanoic acid in the presence of base, that means ammonia or pyridine. So in this case it forms RCHCOO alpha beta dicarboxylic acid. Alpha beta unsaturated dibasic acid is formed here. So here elimination product is H2O because it is a condensation polymerization. That means it is formed by two different functional group of monomers and eliminating byproduct. So in this process elimination byproduct is water molecule. So here condensation of aldehyde and melanoic acid in the presence of base, that is ammonia or pyridine. So in this case it forms alpha beta unsaturated dibasic acid is formed. And again it is undergoes decarboxylation. Decarboxylation, that means minus CO2. So in this case it forms this product name is alpha beta unsaturated acid. Acid is formed. So this is called Newangel reaction. And one more example is Newangel reaction is here carried out in water medium because it is an aqueous medium between aromatic aldehyde. Aromatic means it containing compulsory its benzene ring and acetonitrile. That means here we are taking melanonitrile. So here salicylic aldehydes and melanonitrile undergoes aqueous medium here in the presence of base. Then it forms 3 cynos. Here its product yield is 75 to 95% of yield of product is we can get in that aqueous phase method of green synthesis. So what is the main advantage of this green synthesis method? There is no wastage of product. That means we can get high yield of product compared to another synthesis methods. And less harmful substances, non-toxic substances produces in this green synthesis methods. So in this session, we'll learn about what is green chemistry, what is the importance of green chemistry and principles of green chemistry discussed already, and methods of green synthesis. In this we'll discussed already aqueous phase methods. So remaining green synthesis method we'll discuss next class. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.